Hey, adapters. Welcome back. Today, our guest is Aaron Rothman. Aaron has 18 years of stormwater and remediation consulting experience working with cities across the United States. Recognizing a need for innovative data capture to manage urban and coastal flooding, Aaron founded Storm Sensor with the objective of managing climate risk through creating intelligent stormwater, sewer, and coastal infrastructure. Today, Aaron and I will talk about Storm Sensor's Scute sensors. These sensors each include an ultrasonic depth sensor, ultrasonic Doppler velocity sensor, a temperature sensor, and wireless data transmission via LoRa. Storm Sensor's algorithms generate valuable insights into your sewer and stormwater systems, empowering you to take action. Hi, Aaron. Welcome to the show.
Hi, thank you, Doug.
Well, we are going to talk more about stormwater here. We're going to talk about a particular product that you have. So let's just ground people first. What is Storm Sensor? We've chatted about this before, but could you give a little bit of background of your company?
Certainly. Well, Storm Sensor works with cities across the United States to kind of map how water moves through our storm, sewer, and coastal systems. So we've deployed in cities across the country, and we focus on deploying really dense data networks to really kind of meter the last unmetered utility, which is about 5 million miles of sewer and storm systems.
Okay, so we're going to talk about one of your specific products here, and that is the Scute sensor. We'll dig into it, but more broadly, what is it?
Well, we can look at this two ways. So Scute is a scale on a turtle shell. So we named it because we were trying to think of things that live in sewers, naturally came up with Teenage Mutant Ninja Turtles. Realized we probably couldn't call our sensors Leonardo and named it after a turtle. So it's a scale on a turtle shell. And then a bunch of different scoots together create the Terrapin network. So I do have my examples of our system. And the idea is that within a sewer shed, so an area of about a mile, or I guess a linear mile, we work with cities to deploy, 10 to 20 of these to really get a decent spatial richness in the data. And what we're looking for is we're looking within, usually it's below ground in pipes or vaults. And we're looking at how full these systems are, how much water is moving through them. If there are any obstructions, we can do different notifications. So looking at critical depth, for example, so being able to measure the depth of water inside a pipe or inside a vault under a manhole and give notifications to cities before flooding happens so they can shut down those streets in advance. So to do this, we built our own sensors. And we originally were going to design a sensor that fit the average storm drain and then assume that everything else was an edge case. And what we found was that in our development, in our testing, there is no such thing as an average storm drain or an average sewer. So every case was an edge case. So our systems are basically modular and configurable. So we have what we call the lower, which measures velocity. So we do Doppler velocity. And then we also measure temperature. And then this is wet. And this is the plate that can sit at the bottom of the pipe or the vault. And then our sensor can be replaced or removed by just pulling it out. So that's the bottom. And then we have the depth sensor. So this was a downward facing depth sensor. And if it's a big pipe and there's no anticipated surcharging, so we're not going to cover up the sensor with water, we can install this inside a pipe. However, most of our systems we have found, while they're designed to be 30% full, they actually surcharge. So we get full pipes and oftentimes surcharge at manholes. So we'll install these in a vault. And what that allows us to do is measure water level inside the pipe and then also inside the vault. And that also allows us to do two critical depth or flooding notifications. So one where water in the pipe is a certain level, and then when we're below the manhole cover at a certain level, our customers can be notified.
Okay, that's great. I'm glad you had to show what it is. And I guess what occurs to me is just as you develop this technology, putting these sensors into these stormwater drains in the different areas, it's a pretty hostile environment. Was there a trial and error part of this? I mean, you've got to make these things very hardy to survive this environment.
We did. And we were lucky to work with Jersey City. They like to be the sandbox of innovation. And they brought us in for our very first customer ready MVP. So in startups, they say that if you're not embarrassed by your MVP, then you waited too long, or very embarrassed. So it was a 3D printed epoxied sensor attached. The top was attached to the bottom with a ribbon cable, and we were in the sewers installing these. They lasted about 3 days. But the city was wonderfully accommodating because they have some issues they wanted to deal with. And we were able to design our sensors to work within Jersey City's combined sewer system. And that is a notoriously upsetting sewer. And because we were able to design our system for those, so not only is it full of sewage and debris and shopping carts and a variety of other bits and bobs that can flow through, it's also tidal and between tide gates. So, and we have, so it's kind of not saltwater, but a lot more abrasive conditions than you might see in normal storm sewers. So that was very helpful.
So you were actually down there in the sewers checking it all out.
I did. I did all of our first installations for the
Okay.
first 10.
Well, tell me a bit about that. So New Jersey, you've worked with them, but then there's the wastewater and there's stormwater systems that are so different in all parts of the country because of geology and such. And so, how does your product kind of adjust itself to these different kind of setups?
So the sensors, like I said, they're configurable so they can be deployed in any of these systems. So what's important though is obviously we have field notes, but all of the customization happens on the software side. So when we enter on behalf of our customers or our customers do it themselves, each of the monitoring points, which is where a sensor is installed, we include the material of the pipe or the vault, whether it's a pipe or a vault, the shape. For example, you can have trapezoids or squares or rectangles or teardrops, circles, any number of things. And we also identify whether there's a surface water connection or it goes to a treatment plant, and whether it's tidal, and then also what kind of system it is. So whether it's stormwater, combined, or sanitary. And then that's what triggers the different types of algorithms and the different types of alerts.
Okay, so working with you, obviously, when they reach out, they want to use the Scute sensor. They're not quite sure how many they actually need, and so you're going to work with them to actually figure that out.
Exactly. And we have a couple of different ways to do that. We have our Surfer Index, which identifies flood risk within urban areas. And then we also have our Stormsight software, which we use internally, but alongside our customers, where we can incorporate their GIS files if they have them, and then work with them to design a network that will effectively monitor what they want to see. And then also we can confirm that we'll have pretty good connectivity with the LoRa network when we're out there as well.
Okay, so I think I read that it's transmitting data every 5 minutes. So how are they literally hooked up to a data network? How's that feeding out to people?
So we have, for each of these sensors, they're connected to a telemetry box. And then this box has a radio in it and typically would have an antenna that's right here. And this radio inside this box communicates via LoRa to a gateway, a LoRa gateway. And this gateway is usually about the size of a shoebox. We'll put it on top of a building. We want to get it as high as we can because line of sight, we can go 12 miles. Typically within urban areas, we have cars and trucks and buildings and all kinds of other stuff. So we like to be within about 3/4 of a mile of that gateway. And so our sensors send via LoRa, which is long range, low power network. So we send that every 5 minutes, and the gateway is cellular. And the cellular network from the gateway sends that data onto the cloud.
All right, so as this data is coming out, a lot of times, people don't even know what to do with data. And so what do you recommend? And it's so that they're getting this data and it's like, well, what does this mean? What are the patterns we're looking for? How long should it take before they start, I guess, making decisions based on the data that the Scute's generating for them?
So that's a really good question. We had one customer, when we were talking to them, they said, I don't want to drown in data. I want to swim in solutions, which is both incredibly nerdy, but also wholly delightful and true.
Right.
So we've worked really hard on the insights that we provide with our software because, customers think they want sensors, but do you really care how many sensors you have or that you have a sensor? What you want to understand is how your sewer system is functioning and where the issues are. So what we do, we present all of the data visually and graphically so you can see how rainfall or precipitation trends match flow rates and temperatures and everything else within the system and how those line up. But then we also provide summary data and summary maps that show average capacity, so how much room is available within the system. We can tie that back to the risk index to see where those risk areas are and how real data or empirical data relate to that. And we also have like baseline conditions and, like I said, the different alerts that we provide that allow them to understand what is happening with their system right now, and then the predictive alerts that we're developing so they can plan in advance. And then, of course, all this together gives them some real data within their systems that helps develop cost-effective and efficient and overall effective capital improvements to address the volume of water that we're seeing now.
Okay, so the part of the mission of your company, what you're hoping to help with the communities, is climate change is coming. We're going to have severe weather events. There's going to be flooding. I'm assuming that the Scute obviously factors that in. Let's say there's a 1 in 1,000 year flood event. It's designed to obviously just keep transmitting data in those situations, right?
Exactly. So that's a really important point that you make, because we're operating in storm events. So we use LoRa right now. The issue with LoRa, though, is that the gateways that we're calling into are AC power. So we're also developing a cellular option that allows us to continually transmit during storm events. And then as far as what we're looking at with the statistical storm that you mentioned, we're able to track that in real time and let our customers know how frequently they have these statistical storm events and at what level they have them. So if they're consistently having 500-year storm events, maybe they should change their planning documents and their permit documents to require systems to be designed or buildings to be designed to handle those heavier storm events than what they originally intended.
Okay, so they get multiple Scutes that they're using in their community. What's long-term maintenance associated with the product?
Battery change once a year or so is
Okay.
about it. Yeah, so some of our customers do that themselves, and some of them hire us just to take care of everything, and they just want the data.
Okay, you sort of talked about how it's connecting with data and such, but it's actually paired with local weather data. Why is that important for what you're doing here?
Because so we're working with tomorrow.io to provide our weather data. And that's really important because, first off, the rain, obviously what's happening within their systems is hyper local. And we want to understand how a rain event at one location is going to affect the locations across the city. And then also how that changes. So being able to measure hyperlocal data or rain data and see how that changes and how that impacts different areas of the community is really important. It also feeds into the different algorithms that we're building to understand how these systems function. So it's not just predicting whether we will have a rain event, but it's the duration of that rain event. It's the intensity of it. So how much rain is going to fall within how short of a period, and also what the prior rain event and how saturated conditions are right now, because the more recent rain events and the more saturated conditions, the less likely the water is able to infiltrate into the ground, and the more the storm system is going to be required to handle it, and oftentimes can't.
Okay, so the Scute is one of your products. It's this technology you've developed. How does it fit with all the other services? You've talked a little bit about that, but are the other products that you offer and the other services, how's it all integrated?
Certainly. So the Scute was the foundational product. We wanted the data, the customers and cities that we spoke to, so they needed the data to make decisions. So that's kind of the foundation of everything that we do. Now that we have this really high resolution, high density data, both temporally and spatially, we can build in a series of different algorithms and a series of different platforms. So Terrapin is the software that is just the basic, here's the data, here are the trends. You can download it to what you will. Terrapin AI is coming out later this year, early next year, and that's more of a spatial representation of trends across the community. It also includes the predictive and real-time alerts. And then we also have Surfer, which is the Stormwater Urban Flood Risk Index. And we developed that because so many cities, when we're talking to them, they want to know where in their communities their highest risk or best return of investment is for a storm sensor network. And that helps us identify where we're at highest risk of flooding. It incorporates a number of different parameters that include everything from economic and geographic, geologic, and physical, but also socioeconomic, so population density and relative income. Because what we've seen is that areas that tend to be have poorer neighborhoods tend to have more pavement, so more impervious surfaces, and they tend to be older, so they're going to deal with a lot more flooding. So targeting those areas first obviously highlights social justice, but also helps cities see how valuable the network is in improving a community and being able to make those changes. So having that risk index at the front end, being able to quantify where within a community your highest risk is, deploy a network, make the changes, and really see those impacts is pretty exciting.
Okay, so you're talking about risk and you're laying it out for them. All right, it's identified the risk, but let's say you're a stormwater planner in some city and it comes down to costs associated with this. I mean, what's part of the explanation when it comes to the cost benefit of what you're offering here?
Certainly. So it's interesting because there are a few different ways you can look at it. A lot of what we do is cost avoidance or risk avoidance. So being able to reduce or limit damages associated with flood events by being able to prevent that flood, or to be able to notify landowners or homeowners or block traffic to prevent any damages. Then there's also the maintenance costs and benefits. So installing one of these networks allows cities to be able to monitor how their systems are functioning from their desks instead of sending guys out and truck rolls. So gasoline is a huge expense for the trucks, time and labor. So being able to almost eliminate that and really target maintenance based on need instead of just checking. So we check the boxes is huge. And then also with the capital improvements, being able to design and size them properly can save hundreds of millions of dollars, because you can design a system, but not really understanding what's happening within it, not understanding how sea level rise is impacting your system, or the frequency of overflows, or the type of rain events that are causing these issues. Then you can design to spend, a few $100 million. And we've seen this happen time and time again, where you design a system and you're still dealing with flooding and you're still dealing with overflows because you didn't have the data. And we do that. And our systems, our basic package, we've priced that so anyone can deploy that at a reasonable cost. And then with the AI, it's about twice as much, but it has the additional analyses in there. So it kind of, it certainly doesn't replace, but it kind of enhances any consulting and engineering work that you would also want done on your projects.
Okay, so we've been hearing at the federal level infrastructure spending that's coming in. It looks like it's actually going to happen with infrastructure spending. And I think about your product, lots of retrofitting, taking what you already existing stormwater infrastructure, and it's going to be a useful product, but there's going to be a lot of new investment and new development. How do you fit in on all that?
Oh, wonderfully. So there are a few different ways that we do this, and our customers are so excited about this because they have been, we have $1 trillion in infrastructure upgrades that we are just waiting to make as a country. Plus with COVID and having to shut everything down, we have projects that are just lining up. And there are a few things that we do. A lot of it is model validation. So we'll have engineers or consultants come in and design a model and then use our data to validate that model. To ensure, again, that the capital improvements, their stormwater master plans are properly designed. But then also, once those systems are designed, being able to evaluate the effectiveness and replicate that in future is critically important. And then, of course, understanding how your system's operating on a daily basis is pretty valuable.
All right, so this is going to be required. A lot of cities, states are looking at adaptation plans, and stormwater maintenance is going to be part of probably most adaptations plans out there.
Yes.
All right, you fit in there.
That is a pretty significant issue that we're dealing with. We've seen so much about the floods, so many floods in the news lately, and it's just been getting worse year after year.
Okay, so you've shown what it looks like, and if people want to learn more, obviously they can go to their website and such, but are there any particular good case studies that they could say, oh, well, how's this being used in the real world? What would you recommend for people to learn more?
We do. We have a couple of case studies that I would be happy to share. They might also be on our website, but I'm not 100% positive about that. So we've got a case study for Jersey City. We have work that we've done in Detroit. We have some work that's done on sea level rise impacting these systems in Norfolk, Virginia, and also looking at I&I in Boston. So those are some of the initial case studies that we pulled together. And then with the projects that we have going in the ground now, we'll be developing additional use cases as well.
Okay, so you're going to be very busy, and you've talked about maybe some products that are coming online, but I guess, to wrap this up, what's next for you? What's coming online?
Well, first I'm taking a vacation after we close our round this month. But we're looking at doubling our size as far as number of people in the next few months. So we're looking for just everyone, mid-level, junior and mid-level software developers, data analysts, data scientists are really building up our data. And with that, we're also doing deployments across the country. We're looking at projects. We have one of our team members in Holland right now looking at a project in Norway and talking to a couple of potential customers out there. So not just expanding nationally right now, but also starting to look globally.
Excellent. Well, Aaron, it's always a treat talking with you and exciting what you're doing. And it's going to be just, the next generation of stormwater management. So you guys are doing some great work. I want to take you into just chatting, but thank you so much for coming on.
Thank you so much for having me. This is wonderful as usual, Doug.